So I'm going to go over the test we had on the 26th of November, which is the Spiral 2 Topic 2 test, just so everyone can see what was going on. Now these questions here I actually pulled from your homework and just changed a couple things, as in just adding the negative here, I think this was almost exact same, and I asked for something different here. So it's all stuff that if you did your homework, you should be good to go. So let's look at the first one here. Now we're doing some algebra. So we're isolating the b here. So we need to take a look and see what everything is. So everything right now is a plus or a minus. So we're just taking it over, and it's going to become opposite or inverse operations, right? So this one here is let's write down the first one. The a here is a plus, so when it comes over, it becomes a minus. And this here is a negative, so when it comes over, it becomes a plus. And then all we have left over is the b left over, and that's it. We're just doing the opposite operations. Now this one here, we're isolating for the m first. We're isolating for the m. So right now, it's attached here with the x. So let's not even touch that first. So let's move this over first. So it's a plus on this side, so when it comes over, it's going to become a minus equals mx. Now we know we want to solve for the m here, so we need to get this x out of here. So if we look here, what's the x right now? The x is a multiply, so when it comes over, it's going to become a divide, or the other way to look at it is we divide both sides by x, and this side is going to cancel out, so we're left with y minus b over x equals m. Away we go. Now this one here, we're isolating for the h. We're isolating for the h right here. So let's move the 3 first. So 3's down here is a divide. So the opposite of divide, it becomes a multiply, which will leave us with 3v equals b squared h. Now these are attached together here, or currently that b is a multiply. So when it comes over, it's going to become a divide. So we go 3v equals b squared equals h. And that's it. We're done along those lines. And each of those were worth a single mark. Now the rest of the test pretty much are EQAO questions to help you get prepared. Now this one here says we have a volume of this. And the question asks, which of the following lengths produces the prism with the smallest height? So we're looking to minimize the height. So what we could do here is we can isolate. We know that volume equals length, width, height. So we want to isolate the height. So let's rearrange our equation. We have length and width, and it's all multiplied, so that's going to equal. So when we move these over, they're a multiply on this side. When they come over, they're going to become a divide. So divided by length and width equals h. So what we could do here is we could go through all these different options, such as 216 divided by a length of 3 and a width of 6. What's that equal? Second, 216 divided by bracket 3 times 6. So that's going to produce a height of 12. So let's take a look again. We just run through all the numbers. 216 divided by 6 times 6. So 216 divided by 36 equals a height of 6. And you can see kind of the pattern how it's getting lower. Let's go again. 216 divided by 12 times 6. So 216 divided by 72 will equal 3. Now if we see the pattern, as these numbers get higher, our height gets lower. We should expect that this one here will be the lowest one. 18 times 6. So 216 divided by 18 times 6 is 2. Therefore, our answer through just pure math is that. We could also just look at it and go, okay, if I times this number times this number, it's going to produce the biggest number possible, right? So this times this, if we create the biggest number possible, this number is going to be automatically smaller, which would lead us to having the 18 be our number. All right, here we are again, rearranging equations, right? So we have volume equals pi r squared h. Now we want to isolate for the what? The radius. So let us go here. We know that the volume is this. So let's rearrange our equation. Right now we have pi times r squared times h. So these are all multiplied. So if we go inverse operations, when we bring them over, they're a multiply on this side, they're going to be the opposite. They're going to be a divide. So our formula is going to be volume divided by pi h equals r squared. Now, we take a look here and there's a 50 here for some reason. How does that 50 get there? Well, if we take a look, we know our volume is 500 and our height is 10. So let's plug in our numbers here. So 500 divided by pi times 10 equals r squared. 500 divided by 10 is going to equal 50 over pi equals r squared. Now we have a square over here, but we only want r. So how do we get rid of a square? The opposite of a square is a square root. So we do this whole side by square root. So we're going to square root this whole side. Now all of a sudden we have something that matches. The key here is we do the whole side, just like we do the whole side here. So we have a match here, so our answer is going to be A. Now, here we have a popcorn container, and we're looking for the surface area. Okay, how much is required to take it? And we have to recognize here that we have this area here, and we have the bottom of this, but we do not have the top. So if we take a look at our formula sheet, which I'm reaching over to grab, and we have a cylinder. So we take a look at our formula sheet. The equation for a cylinder is 2 pi r squared plus 2 pi RH, where this here is the top slash bottom, and this is the lateral side of the shape. So we need the lateral side, so we're going to keep all that. But we only need the bottom. We do not need the top. So instead of it being the top and bottom where we have 2, we only need one of these. So that's going to give us pi r squared, which then takes this one out and this one out, because it doesn't have that second part here. We're missing the lateral space. Now we take a look at the different equations, and the only difference is the 9 and the 18. When we take a look, that 9 and 18 is the radius, but this whole space is 18, and we know that radius is only half of that. So I'm looking for this part, so that's going to be 9. So since we know it's 9, we're looking here. That's C, getting our answer. Alright, so this is actually a tough question. We're looking for the surface area of the shape, and it's not a traditional shape, right? It's a couple, the top and the bottom that are rectangles and a trapezoid. So let's take care of the easy part first. Let's do the top and the bottom. We're looking for surface area, so we're going to add up our surface, add up the areas of the exterior surface. This is 17 by 17. Let's do this over again. So let's do, the top is this, the green. So we're here, 17 by 17. So area equals length times width. So that's going to equal 17 times 17, which equals, here's my calculations, 289. 289. That'd be centimeters squared. Now our second one is a little bigger, and that's the bottom. And let's do that in a different color. Let's do that in blue, which is around here. Oh, that's 35 by 35. We're going to do the same thing. Area equals length times width, which equals 35 times 35, which equals 1, 2, 2, 5. So that's the top and bottom done. Now we have this side here. We have this side here. So we have a trapezoid, like such. This is 17, and this is 35, and we know the slant is 40. Well, if we look at our formula for trapezoid, it is, where are we here? We'll label this A, B, H. So it's A plus B times H over 2. Now we have A, right? A is 35, 17. We have B, which is 35, but we don't have height. But we don't have height. So how are we going to find that height? Let me redraw my trapezoid here. We could make a triangle here. Now we know that's 40. We know that's 17. We know that's 35. So we know this whole distance 35. And this distance here is 17. So if we go 35 minus 17, that's going to equal 18. So that means we have 18 between here and here. So which means this would be 9 here, and this would be 9 here. So we put 17 in here. 9 plus 17 plus 17 equals 35. So now we have a right triangle that looks like 40 and 9. Now if we remember our Pythagorean theorem, that equals c squared minus a squared equals b squared. We'll label that one b. So it'll be 40 squared minus 9 squared equals b squared. And for the sake of time and you guys watch me scratch this out, after we do that calculation, b is going to equal 39. So now I can plug this into this spot here. Now I do this whole calculation, I get 1014. Now we have to remember we have 4 sides, 1, 2, 3, 4, so I'm going to multiply this by 4. So that's going to equal 4056. Then my total is going to be, so pink, this, plus this, plus this. I'm going to add those all together. I get, where's my mouse gone? 5,570 centimeters squared. That's my final answer. Hypothetically, it should have been a little more worth than 3 marks, but I'm fine with it for right now. Now this one here, the diagram shows a half cylinder, so we can look up our formula right now for a cylinder, and we're looking for the material cost, so we're looking for surface area. And this is the same formula we were looking at before. We had 2 pi r squared plus 2 pi RH. Now, if we look at the question here, the shaded area does not need to be covered. So this here and this in here doesn't need to be covered. So those are my circles. So I can get rid of this spot in my formula. Now, if I figure out what my radius is, I know my radius is half of this. So if it's all the way across is 20, my radius is going to be 10. So let's plug in my numbers here. So I get 2 times pi times 10. And my height here is 80. That is going to give me a total of, I think, 5,026. Let's see here. Yeah, 5,026. So 5,026. Now, I only have half a cylinder, so I'm going to divide this number by 2, which will give me 2,513. Now, if I look here, that answer is not there, but it says $3 per square meter, and this is square meter, so I'm going to times this number times 3, which is going to give me a number close to, if not bang on, this one here. Now, the first part of this question is realizing what you're looking for. So realizing what the x's are. We have to recognize that we have a polygon here of 1, 2, 3, 4, 5, 6 sides. So we have to go back to prior knowledge where the interior angle, inside angle, equals 180 multiplied by n minus 2. In this case, it's 180 minus, 6 minus 2, which is going to equal 180 times 4. If I press equal, where's my time? 720. So we know that all this equals 720. So now we can go 720 equals, and we're going to pick a point, so I'm going to pick this point here and work my way around. 120 plus 5x minus 6 plus, 4x plus 14 plus 7x plus 8x minus 8 plus 6x. So we have this here. I've worked all my way around the circle. So now we're going to collect our like terms. So we have x's here, like such. Then Then we can go from here, we add all those numbers up, we get 30x plus 120. Now we're isolating, so we're going to toss this over to the other side. So we have 720 minus 720 minus 120 equals 30x. Which is going to equal 600 equals 30x. Now from here, we have to get rid of that 30, so we're going to divide both sides by 30. Divide by 30, we're going to get x equals 20. Now we go on to the second part of this thing. Solve with any two of the unknown angles. Let's pick any one of these. Let's pick this one. So it's 7 times x, so that means 7 times 20, which is going to equal 140. Now let's pick this one here. We're going to go 4 times 20 plus 14 equals 80 plus 14, which is going to equal 94 is my number. I can keep plugging in any one of these around. So we're building a shed that's 500 square feet. What's the optimal dimensions for a four-sided shape? So we have area here. So if you remember back, my optimal shape for a four-sided item to minimize perimeter and maximize area is a square. So it means all the sides are the same. So let's just name this side and side. If we take a look at our area formula, area equals length times width. In this case, area equals, if we plug this in, side times side. And side times side is going to equal side squared. And let's plug in the number here. And we need to find what one side is, so we're going to take the square root of this. The square root of 500 is 22.4. So therefore, my shape is going to be 22.4 here and 22.4 here, all the way around. Those are the optimal length and width of that shape. Now, we need a three-sided shape. As we talked about, a three-sided shape looks like this. X, X for widths, and 2x for length. So, let's go back to our formula for area. Length times width. Now, my length is 2x, x, and my width is x. So now I have to multiply these together. So 2x times x is going to be 2x squared. Let's plug in my 500. Now I need to isolate for the x, so I need to get rid of this 2 first. Let's divide by 2. That's going to equal 250 equals x squared. Now it looks a lot like this over here, so we're going to take the square root again, get down to x. So x is going to equal, where's my number, 15.8. Now we know that's x, x, 2x, so this side is going to be 15.8. This side is going to be 15.8. And the last side here is going to be 15.8 times 2, which is 31.6. That's my optimal shape. Now last one here, I'll run through some ways you can get it. But this here, you're creating a container to hold 1,000 liters. I tell you right off the bat that 1,000 liters is 0.1 meters squared, because we don't really know what a liter is. So we're going to go 100,000 liters. So first of all, to get meters squared, which we know what we're going to do, we're going to times this together. So that's going to give me 1,000 meters squared. So now we know what we're aiming for in shape. Now I gave you anything you can do here. So the most logical shape I could make is a rectangle. And let's make it easy. We know we need 1,000. So 10, 10, and 10, right? So if I need my volume 1,000, if I go length, width, height, it's 10 times 10 times 10, which equals 1,000. Perfect. Now I need to look for the surface area of that shape. So surface area of that shape is going to equal, where's my surface area formula? Right side is 2 times width times height plus length times width plus length times height. So all my numbers are 10, which we went over before. So that's going to be 2 times 10 times 10 bracket, plus, or go 10 times 10 again, plus 10 times 10. What's the odds this will give me my answer? No. Oops. Perfect. So if we go 2 here, 10 times 10 is 100, right? So it's going to be 100 plus 100 plus 100 equals 2 times 300, and that's going to give me a total of 600. So that's one option. Right? I'm not going to run through all the options here, but let's take a look at my optimal one. My optimal one is a sphere, and that's a horrible sphere. Let's go backwards and see if I can insert a sphere here, which I cannot. So let's make some as close to a sphere as I can get. Let's pretend that's a sphere. Now we know that the formula for a sphere is volume equals 4 pi r cubed over 3. Now I know my volume is going to be 1,000, and I want to isolate my r here, so I got to do some algebra. Let's bring this over. This is a divide on this side, so it's going to become a plus. I mean, not a plus. Divide becomes a multiply. So we have 3v over 4 and pi here are multiplied, so we're going to come over and become a divide. Now let's take a look at, put some numbers in here. So it's going to be 3 times 1,000 divided by 4 pi. So that's going to be 3,000 up top. So where's my answer key? I'll have to do this with you because I wrote out the answer before, but I misplaced it. So that's going to be 3,000 divided by 4 pi, which equal, I think it's 216 if memory serves me right. 3,000 divided by 4 pi equals, that's not right. $238. So 238 equals r cubed. Now, we need to get rid of that r cubed. So we're going to do the exact same thing we did here. Let's move the r cubed over this way. We're going to do the exact same thing we did in the previous page. We're going to take, not the square root, because before there was a square there. We're going to take the third root. And the third root on this side. So the third root of r cubed is r. And the third root of that number, one second here. Just want to make sure, I think it's 6.2, but I just want to make sure. 238, right? 6.2. Now I know this tells me that a sphere with a radius of 6.2 will hold 1,000 meters cubed of material. That should be a 3 there. So that allows, I know that my stuff will fit in there. So let's go to surface area now. So surface area formula is, for a sphere, 4 pi r squared. Then we can go 4 times pi. Now my r squared now is 6.2. Let's plug that into my calculator. 4 times pi times 6.2 equals, oh, I forgot to square that. 4 times pi times 6.2 squared equals 483. 483 meters squared. So you can see that this one here is quite a bit lower than that one there. So this one here would be my optimal answer. Nope. So there's my optimal answer right there. Now you could also do a triangular prism or anything like that, but the sphere is going to be my optimal number. Okay, hopefully that helps out. If you have any questions, please come see me anytime you wish.